Okay, chemistry aside, now it's algebra time. Still doing the calculator, so in that sense it's a continuation from Wednesday because it's definitely calculator heavy, but it's new buttons on the calculator. It's not the same stuff as Wednesday. So don't be like checked out thinking, oh yeah, that was pretty easy, I figured all that out. I mean, I hope you feel that way, but this is newer, different stuff today. So we're on number 4. And today we're going to do 4, 6, and 8, and that will basically complete the packet. Or not the packet, but at least this worksheet. Assume that the number of liters of water remaining in a bathtub varies quadratically. Well, that sounds really fancy, but really all that means is it fits a quadratic equation. Varies quadratically. Sounds fancy. Just means it can be modeled with a quadratic equation. So it varies quadratically with the number of minutes which have elapsed since you pulled the plug. Okay, so maybe we should be a little more specific here. The liters vary with time, so AT squared plus BT plus C. So they didn't really give us an equation, they gave us the form of the equation. So thanks, I guess, but I don't know what A, B, and C are. If the tub has 33.4, 16.6, and 4.6 liters remaining at 1, 2, and 3 minutes respectively, do we know what that means when it says respectively? Not like respectfully, like we're going to owe honor and deference to these numbers, like not that. Like in order. So when the time was, after 1 minute there were 33.4 liters, after 2 minutes there were 16.6 liters, and after 3 minutes there were 4.6 liters. And I think that makes sense because we're draining a bathtub, so we started with a lot and we're headed towards 0. Write an equation expressing liters in terms of time. Okay, well we've started that. Like I don't know what A, B, and C are, but at least I know what it looks like because they told me it varies quadratically. So quadratically would be the key there to let us know what kind of equation it is. Okay, I don't like the data when it looks like that. That's like I feel like my brain has to hop back and forth. So I'm going to put it in a table. So it's just rearranging the data to look better. I'm also going to put the time on the left because that's the independent variable. The liters will go on the right because that's the dependent variable. How many liters are left depends on how much time has elapsed. So that's the same information. It just looks better to a math teacher when it's in a table rather than written out in words. Right, an equation expressing liters in terms of time. Okay, here comes the calculator part. Because our calculator can take those 3 points and figure out what equation would match those. There's a way to do it by hand, but it would be 3 equations and 3 unknowns, and the equations would have t squared in them, and so it would really be hard to do by hand. What this is called is regression. Sounds bad, like we're regressing, and we're not going backwards. We're doing a regression which fits a formula to the data. This really is real world stuff here. Like you take some data, but you want to know like, well, what is going on here? Is it quadratic? Is it linear? Is it exponential? And so you try different regressions and see which one fits. Now, this one they told us which one fits, so that's a little bit easier than if you were just out trying to figure this out on your own. Okay, so for the calculator part, let's first talk about where and how to enter the data. And then we'll talk about how to get the equation. Okay. So, you guys being first period, you kind of experience what I experience every year because I don't use this very often. So you get a real world, like how do I remember where to go? I know this is statistics stuff, like all these numbers. So I'm going to go to stat. It's sort of like when you're trying to find y1, you know you hit vars first, and then you can probably figure it out from there. This is kind of the same thing. There's a lot of buttons, but if I hit stat first, I can probably figure out what I want to do from there. Let's see, edit, calc. I don't want to do any calc or test. That's statistics. If any of you take statistics later, you'll figure out what all that stuff is. Right now, I just want to edit. I want to make a table with my information. So stat and then edit. And if you laid out your table well, then the table on your paper should match the table in the calculator, because the x values go into L1 and the y values go into L2. So let's type those in and let's make our calculator match our table. So 1, and I guess you can just put all the x's in first and then go over and put the y's in. Oh, 16.6, thank you. But that's a great catch, because needless to say, maybe if you put the wrong y values in, then you're going to get the wrong answer, and I would say it wouldn't be your fault. It wouldn't be the calculator's fault. Just, you got to make sure the data is in there correctly. So I'm glad you caught that.
Do you press enter?
I think you press enter if you're changing something. Yeah. Or just arrow to a new spot. But make sure that the table shows your new entry, right? Like right here, I'm trying to say that that's 33.2, but until I hit enter or move, it still thinks it's 33.4. Of course, it's supposed to be 33.4, so let me change it back. So make sure your table matches, make sure your calculator table matches your on-paper table. This would be one spot where you don't have to do the on-paper table. Like once you get good at this, you just open up the calculator and you put all that stuff in the right place. But I don't know, I think it's worthwhile to draw it out by hand. Okay, so now the calculator knows what my table is, what my x's and what my y's are. So next we need to figure out how to get the calculator to find the equation. To get the equation. I guess maybe at the end of this we should say second quit, because we need to get off of that screen and back to our main screen there. So put everything in, exit out. The calculator still knows it, it's not lost, it's still there.
How do you exit out?
Second quit.
Thank you.
You're welcome. Alright, to get the equation, we're going to go back to that same spot, or at least close to the same spot. We're still doing statistics stuff. So stat again. But now we want to do some calculations. Like we already edited our table. Now we want to do some work. So go over to calc. And if you read those options, you might be able to figure out which one we want. Quadratic regression, number 5. Because a regression means fit a equation to the data. And so you have options. You could fit a line to the data. You could fit a quadratic to the data. You can fit a cubic to the data, or a quartic, or a linear, or a natural log, and all this other stuff. Sine, we don't need all that. We just want a quadratic regression. Quadratic regression. So either just press 5 or press enter when you're highlighted 5. And now we've got some stuff to fill in. It defaults to this, and the default is good. But I want to add one thing to that, and that is to store the regression equation. If you don't do that, actually, let's just do it right now and see what happens. So just scroll down to calculate. Go the easy way first, and then we'll talk about one extra change. So hit enter on calculate. It thinks for a minute, does that pretty quick, and then tells you what the equation is. The equation that fits your data. So now, and it even lays out, reminds you what the formula should look like. So y equals 2.4x squared minus 24x plus 55. Okay, I guess we'll just call this optional, what I'm about to show you. To store that equation in y1. So you can, we're going to do stuff with that equation, so we're going to go type that equation into y1, but we can skip that step. We can tell the calculator to put that equation in y1 for us. So rather than us having to write it down and then type it in, we can just say, calculator, you stick it over there. So back to stat, so quit, stat, calculate, quadratic regression. So I guess we could say it goes right here. Before you hit calculate, frequency list, I don't even know what that means, but store regression equation. If we'll put y1 there, it will put that equation in y1, and it just saves us the time of typing it in. So do you remember where we get y1? I mentioned it earlier. Vars. So vars, we want a y var, we want it to be a function. I want to put it in y1. I suppose if you already had something in y1 that you didn't want to mess with, you could put it in any of the other y's, but we'll just stick it in y1.
Why do you need to add y1 again?
I'm telling the calculator that once it finds these values, to put that equation in for y1. It just saves me a step.
It just makes you like y equals 2.4.
So when I hit enter on this calculate, it's going to tell me the same thing, but now if I go to y equals, it should be there. Now this looks weird because it did some rounding, but 2.39999999999, I'm pretty sure that's 2.4. So it just had a little bit of a rounding issue. It plugged it in for me. So it saves you the step of typing all of that into y1. And for this one it wouldn't be bad, but occasionally you do these and you get lots of weird decimals, and rather than writing them all down, you just tell it to, hey, just go stick that in y1 for me. Then I can look at the graph and find all sorts of stuff.
What is the first thing you wrote down in your optional?
Sorry. To store the equation in y1.
Okay.
Again, not mandatory, but it saves you some time. Okay. Now we've got an equation. Now we can answer all the questions kind of like yesterday. But the front end of this was fitting an equation to some data. And again, the key thing is stat. After that, or maybe stat edit and stat calc. Those are you can figure it out from there. If you get the stat edit, it brings up a table, you'll know what to do. If you get the stat calc, you'll recognize quadratic regression. So, you got to know or memorize a little bit, but you don't have to memorize everything.
Is that where term comes from? I need this now, like stat.
I need this stat. Now, I think this is just short for statistics. I don't know what that stat is short for. Okay, how much water was in the plug? How much water was in the plug? How much water was in the tub when you pulled the plug? How am I going to figure that out? At 0. So, because time elapsed since you pulled the plug, well, when you pulled the plug at time 0, so I want y1 of 0. So I could use the calculator, I could use the table, I could use the vars thing, but I could also know that plugging in 0 is really easy. And what's my answer going to be? 55. If I plug in 0, I'm going to get 55. 55 liters. When will the tub be empty? So how will I figure out when the tub will be empty? When L is 0. When liters are 0. So 0 equals 2.4 x squared minus 24x plus 55. Okay, I have options here.
You could just use the go to the next.
Okay, so let's look at the table. I don't think the table is going to give me the exact answer, but it's not a bad place to start. Thankfully, the first 3 points match our, or at least 3 of the points match our initial data. We can also see that we started at 55. So narrow it down. When did L hit 0? Between 3 and 4. So the table is helpful, but it doesn't really answer the question.
Say 4.
I mean, it's definitely empty at 4, but I want a more accurate answer than by 4 it's empty. I want to know when it's empty.
3.5.
I mean, maybe.
3.67.
Well, you tell me. There's options here. This is a quadratic equation, so I could solve it with the quadratic formula. I'm going to look at the picture because I'd like to see what's happening here. Okay, I think we can make sense of this. I'm going to change my window because I know it's going to start, like what's my y-intercept? How high do I need to go to see my y-intercept? 55, because that's where this thing started. And we know it reaches 0 sometime between 3 and 4. We don't know what that number is yet. And this is a little bit like yesterday where the model is a parabola, but like once L is 0, the model doesn't really mean anything anymore. Right? We don't have like negative liters in the bathtub, and then a few minutes later it starts like filling up mysteriously, whatever. Like, so once we hit 0, our model is kind of done. We don't need the rest of this. What we're concerned with is we started at 55, we end at whatever that spot is. Okay, so finding that spot. I can use the quadratic formula, but I want to show you a different way. I would like to find that 0. Some more calculator work here. We want to calculate some stuff. So while we're on the graph, there's a button that says calc up there. I want to do some calculations on my graph. So second calc. And this is nice because this can find all sorts of things. But I want to find the 0. So you press enter. And this is another one where there's lots of buttons, but if you can remember calc 0, you can figure it out. Left bound means, I'm trying to find my cursor, there it is. So scroll left or right, figure out where your cursor is. Left bound means get to the left side of the cursor, or of the 0. So that's the 0 I want. Left bound means just get to the left of the 0. What you're doing is you're telling your calculator where to look for the 0. So you need to give it a left bound and a right bound, and then your calculator will look in between there to find it. So you have to tell it where to look. So left bound, as long as you're left of the 0, you can hit enter. And then it says right bound question mark. So you've set the left end. Now you need to scroll over and tell it where to stop looking for the 0. So get to the right of the 0 and press enter. And if you notice there's a couple of arrows up there, that's telling you that you set the bounds here and here to tell the calculator to look for the 0 between here and here. Next, it asks for a guess. You can be like kind to your calculator and get it closer if you want to. You can also just press enter. So like if you press enter, he starts looking here. If you move it around, you can make him start looking here. And it does save like milliseconds, but you won't even notice how quick it goes. So there's my answer. 3.557. You almost got your 6.7 there.
Oh, I was so close too. Wait, can we just round up 5 or no?
Well, you couldn't round that to 3.67.
No, I was so close.
You could round it to 3.6, I guess. Or 3.56. But not 3.67.
Is it? Oh no, it's T.
And it's t. I mean, your calculator is going to say x, but you know that the x variable is time. So, second Calc 0. You will use this. In fact, there's a student back there taking a calculus test. She's probably going to use that in a few minutes. The Calc 0. When she gets to the calculator part of that test. So, Calc 0 is a big one. The linear regression, or the quadratic regression, you will not use that very often. Some of the stuff you won't use often, but Calc 0, that's super handy.
It's not working on my calculator.
Uh-oh. What's it telling you?
It's just stuck. Like I turn it off and on and then. And whenever I zoom out, it's just like really slow. And whenever I zoom out, it's just
Okay, you don't have the right, so put that, change that formula to be the right formula.
Oh, that's
All right, question D. What is the lowest number of liters the model predicts? Well, where would we find the lowest number? That would be the vertex again. How do we find the vertex?
B divided by
Well, the negative b over 2a is the best, well, not the best answer. It's one of the answers. That would be the x-coordinate of the vertex. So 24 over 2 times 2.4. I think that's going to work out to be a nice answer. That's going to be 5. Okay, well, let me finish this thought and then ask that question, because the answer is going to be yes. But this is the time when we're at the vertex. How do I find the liters at the vertex? Just plug it in. And since it's a nice number, it's probably on the table. So the lowest number that the model predicts, the model is that equation, is negative 5. But is that number reasonable? No, like you can't have negative 5 liters in the bathtub. Like once it's empty, it's empty. No. I don't know why or why not. No negative liters. Okay, Mason, you saw something earlier, I think. So we're looking at the graph. We're like, hey, there's a minimum. And when we were on that calc page, there was a minimum option. So you can use the calculator on the graph to find the minimum, and it walks you through those same steps. Left bound means get to the left of the minimum. Press enter. Right bound means get to the right of the minimum. Press enter. And then you can just press enter again for the guess. It thinks for a little bit. And 4.999999983, what's that equal to? 5. So be careful when you're using your calculator. Like it does things numerically, so sometimes it gets a little bit weird at the very end. But to the nearest 3 decimals, that's 5. What is a reasonable domain and range for this situation? We've done this before. Domain would be time. Range would be liters. So what's the time span that I care about for this model? 0 to 4 isn't bad. I think they want you to say 0 to 3.557, because that's when you run out of water. After that, the model doesn't really mean anything. And how about the range? What values of liters are meaningful? 0 to 55. I mean, it goes up past 55, but that's in negative time. It goes below 0, but that doesn't make sense. So that reasonable domain and range means like what is helpful. In fact, if we wanted to graph this, this would be the window that we would want to really look at. Okay, so stat, edit, stat, calc, that's the main new things, and calc 0 for today. Kinley?
I'm still, I haven't been in the big.
Okay, let me move on and see if you can pick it up on this one. All right? The y equals? Number 6. I mean, I get to number 8, and that might be okay. We'll see. Number 6. On a trip to St. Louis, you visited the Gateway Arch. I went there last summer. I'm a fan. You have plenty of time on your hands, so you decide to estimate its height. I did not estimate its height. You set up a coordinate system with one end of the arch at the origin. Okay, so it's telling us how to set this thing up. I don't know if you've been to the arch or at least seen the arch, but looks something like that. And this told us to put one end of the arch at the origin. The other end of the arch is at x equals 162. To find a third point on the arch, you measure a value of 4.55 meters when x equals 1 meter. You tell me, does that seem like it would be the vertex?
Oh, no, wait, no. Absolutely not.
Absolutely not. What that did was gave me 3 points. It didn't really say it quite like that, but 0, 0 is on the graph. 1, 4.55 is on the graph. And then 162, 0 is on the graph. So now we can put that into stat edit. And then we'll do stat calc to find the equation. So see if you can get to an equation that would mirror or match what's going on there. 8:10. We got 10 more minutes.
Oh, I'm sure it's a pep rally.
Pep rally day. Blinged out pep rally. My bling is that I'm wearing a Baylor national championship.
Yeah.
So we're celebrating our championships. I'm celebrating Baylor's championships. That's my link. Okay, but you're typing in those points and seeing if you can remember all the buttons to get to an equation. So you're trying to answer part B. Find the equation for the underside of the arch. Stat edit. So there's what your table should look like. I mean, it should match exactly what your written table should be. Oh, that shouldn't be 0, 1. Good catch. 0, 0. Having trouble entering my tables today. Okay. I think I would have double checked that before I exited because your calculator is not going to make a mistake. It's only going to take your bad data and mess it up. So make sure my data is correct. Max caught my error. Second quit. And then stat calc. And I'm trying to fit a parabola. So that would be a quadratic regression. And I want to do the shortcut thing so that I don't have to type in all those numbers. So I want to store the equation in y1. Again, you don't have to do this step, but it saves you a little bit.
What just happened?
Well, you get like a
How do
bunch
you
of
get that? Because
same
when I do
numbers.
that, it just
So
puts quadratic.
How do I do what? Let me back up.
It just goes to that. It doesn't go to
Calc,
and then do
quad regression.
Yeah, that's it. If we don't get, I don't
You don't have that option? Okay, so you'll just hit enter and you'll have to type them in manually. Do you have a slightly different calculator?
No, it's the same.
Okay, just hit enter.
Yeah.
And there it is.
Oh, so that's the.
it still didn't work.
So it
I did the one.
It works, but yours, it's like an operating system thing. Yours has a earlier operating system that won't do that for you. So yeah, if you don't have that option, if it just says quad reg, hit enter, and it'll spit it out for
You
you.
have a special calculator.
You got a special calculator.
Supposed to have the E. Wait, yeah. How did you just do that?
Okay, how did I get Y1?
That's what I said.
Okay. Where do I find the Y1? What is Y1? Where did we find it yesterday? Vars. So go to vars. And then I want a Y var. It's a function, Y1.
Go to skip that, go to store that, then go to bars.
Okay, we'll talk about those numbers in a minute. What are you looking at? Okay, so you can just hit enter or calculate.
Yeah, that's
But
what
if
I
you
know.
want to store it in Y1 right now.
I don't know what to route out.
Okay, what does 1.26 e negative 9? You guys were talking chemistry earlier. That's
Negative 9
so what if I rounded that to 3 decimals? What's that going to be? 0, because that's 0.00000000126.
So C equals 0.
So C equals 0. But your calculator is trying to be super accurate, but C is 0. We want 3 decimals, so 0.028 x squared plus 4.578 x plus 0.
Oh wait, we can't round it. So.
I'm rounding to 3 decimals.
Oh. Oh yeah.
Let's see. X coordinate of the vertex. Well, you have options here. You could do negative b over 2a. Or you could do calc max on the graph and have the calculator find the maximum. So y equals, and there it is, super accurate with all those decimals on there.
Where do you get the calc facts from? Is it maximum?
So I'm going to graph.
Air.
Window. I got to go to 162. And I don't know how high this thing is. 200 maybe? I have no idea. 200 was a good enough guess.
Where'd you put 200?
For my Y max.
So why not?
Max.
Where do you go?
Change your window. Change your X window. I knew what my X window should be because they kind of gave that to me. And then I guessed on my Y window. Second calc, I want to find the maximum. I can barely see the cursor, but it's there. And so there's my X coordinate. Again, a lot of weird decimals, but if I round that to 3 decimal places, that's 81.
Can you do that all again, but still down?
Yeah. Hey, actually, I probably should have figured that out at the top, right? If my two x-intercepts are 0 and 162, then halfway in between there should be 81. Back up. If you want the maximum, second calc. I don't want a 0, I want a maximum. And then it walks you through the steps to get there.
I get error.
Wait, but I don't know linear thing. How did you change yours from linear to
Window.
And then my Y max, my max is already there. I already found it. 85. All right, we'll stop there. We'll finish number 8,
Okay, yes.
or we'll finish this on Monday.
Yeah.